Welcome to the Explainer. You ever stop and wonder what's actually going on inside your phone, or your smart thermostat, or even your car? It really all comes down to one simple thing: making decisions. So today, we're going to pull back the curtain and see exactly how code thinks. Let's get into it.
Whoa, okay, at first glance, this looks pretty complicated, right? A huge, tangled web of logic. But what if I told you that every single box and every arrow on this chart just boils down to a simple if-then question? Yeah, the exact same kind of choices you and I make every single day, just a lot faster.
And that really brings us to the big question for this whole explainer. We make choices based on our gut, on experience, on what we had for lunch. But how does a machine, a piece of software made of circuits and code, actually make a decision?
Well, to answer that, we've got to start with the art of the choice itself. And you're going to see that the logic a computer uses is probably way more familiar and intuitive than you think.
Think about this sentence for a second. If it's dark, then turn on the lights. It's so simple, right? This is a perfect, real-world example of what programmers call conditional logic. You check a condition, is it dark? And if the answer is yes, if that condition is true, you perform an action. Believe it or not, you already get the fundamental idea behind how all software works. So let's see how code actually uses that simple logic. It all starts with the most basic building blocks in all of programming, the if statement and its partner, if else. These are, hands down, the main ways a program looks at a situation and decides which path it's going to take. First up, we've got the single alternative decision. This is just like our light switch example. We have one condition, and if it's true, we do something. But what if it's false? Well, in a single alternative choice, the answer is nothing. The program just shrugs and moves on to the next thing. Think about it like submitting your homework online. The logic is dead simple. If the homework is completed, then submit homework. But what if it's not completed? Well, you just don't do anything, right? There's no other action. You just wait. That's a perfect single alternative decision in action. But what if you need a plan for both possibilities? That's where the dual alternative comes in. This is your classic if-else statement. If the condition is true, you do one thing. Else, if the condition is false, you do a totally different thing. It covers all your bases. The umbrella analogy is just perfect for this. If you have an umbrella, then you will stay dry. That's path number one. Else, you will get soaked. That's path number two. See? A dual alternative makes sure there's a specific outcome no matter what. It's a complete plan. Okay, so simple if-else is pretty powerful stuff. But let's be real, life is usually more complicated than just one question. And that's where we get our logical power-ups, the operators and, or, and not. These little guys let us build much more interesting and sophisticated decisions. Let's start with and. The one thing you have to remember for and is this: all of the conditions have to be true. If you're checking, say, 3 different things, and you connect them with and, every single one of them has to be true for the whole statement to pass. If even one little part is false, the whole thing just fails. I mean, think about going grocery shopping. For you to succeed, 2 things must be true. You need money, and the store has to be open. If you've got a pocket full of cash but the store's closed, no groceries. If the store's open but you've got no money, same problem. The key here is that and is for when every single piece of the puzzle is mandatory. Now let's look at its way more flexible cousin, the or operator. With or, the rule is totally different. Now it's at least one condition must be true. As long as just one of your conditions is met, the whole statement is considered true. It gives you options. For example, think about getting to work. If I have a car or there's a bus available, I can get to work. You don't need both, right? Just having one of those options is enough to get the job done. So or is fantastic for creating backups or just having multiple ways to get to the same result. And finally, we have the simplest, but sometimes the most mind-bending operator, not. All not does is flip the value of whatever comes after it. It just reverses it. So a true becomes a false, and a false becomes a true. It's basically the logic of opposites. So in this case, the action, staying home, happens when the store is not open. If not open is really just a programmer's way of saying if the store is closed. This lets us check for the absence of something, which, as it turns out, is an incredibly useful thing to be able to do. All right, so now we have our building blocks: if, else, and, or, and not.
Now for the fun part. Let's see how these simple little tools get combined to create the really complex and intelligent logic that powers pretty much everything around us.
Okay, a super common task for code is checking if a number is inside a specific range. And we can do that by mixing our comparison signs with the AND operator. But notice the subtle difference here. On the left, using greater than or equal to creates an inclusive range, meaning it includes the numbers 65 and 75. On the right, just using greater than creates an exclusive range, which only checks for numbers strictly between 65 and 75.
But what happens when you start mixing all these operators together in one big statement? Well, things can get confusing fast. Just like PEMDAS in math class, please excuse my dear Aunt Sally, programming has its own order of operations. And the most important rule of all is that parentheses are king. Anything inside them gets evaluated first, period. After that comes not, then and finally or. And this is exactly why that order matters so much. Just look at these two examples. They use the exact same letters and the same operators, but those little parentheses completely change the logic. On the left, the computer groups B and C first. But on the right, the parentheses force it to group A or B first, which leads to a totally different result. It's a huge deal.
So what do you do when you have a situation with tons of possible paths, not just one or two? I mean, you could write a super long, messy chain of if-else statements. Or you could use a much cleaner, more elegant tool called a switch or case statement. It's designed for exactly this, checking one variable against a whole list of possible values. The perfect way to think about it is a traffic light. The variable is the color of the light. The program just checks the case. Is the case red? Then stop. Is the case green? Then go. And there's even a default case for when the value doesn't match any of your options, kind of like an error message. It's just a really organized way to handle multiple fixed choices.
So, when now you've got the tools, you understand the basic logic gates that build our entire digital world. And the source material for this explainer ends with a challenge, so I'm going to pass it right on to you. Using and, or, and not, can you create a tricky little logic puzzle to stump your friends? It's a really great way to see if you've got it down.
And that really is the biggest takeaway here. Every app, every video game, every piece of AI, no matter how incredibly complex it seems on the surface, it's all built from these surprisingly simple logical decisions we've just talked about. It's not magic. It's just building a complex world from simple, understandable choices.